section 10.3, we're going to be talking about something called experimental probability. Last time we spoke on the term probability, and it's the number that represents the likelihood that an event will occur. Basically, it's the favorable outcomes divided by total possible outcomes. And we talked about that last time. It was pretty straightforward, wasn't all that difficult. Another thing that we like to call this type of probability is very important. We actually call this theoretical probability. All right? Because theoretically, I can have a certain number of outcomes, but in reality, I may not. I may not have that exact same probability when I actually do something, which gives me to the next point, which is called experimental probability. And it's the probability that is based on repeated trials of an experiment. And what we end up doing is we find the probability of a particular event, and how we do that is the number of times an event occurs versus divided by the total number of trials. So let's go ahead and break this down. You're actually going to do an experiment with me. We're going to do something, we're going to compare theoretical probability to experimental probability. So at the front of the room, you should see a little cup, yogurt cup, and inside that yogurt cup is a bunch of cubes, much like you see in front of you. When you go up there, I want you to get this. I want you to get 2 green, 1 brown, and 1 black. I want you to get these particular colors. And if they're out for any odd reason, please share and do this little experiment together, or you may have to choose you some different colors. Just remember, I want 2 green, 1 brown, 1 black, okay? Now, with that said, what we're going to look at is 2 things. We're going to look at, first off, theoretical probability. So theoretical probability is the number of favorable outcomes out of the total possible outcomes. So I have a total of 4 cubes here. So there are 4 possible outcomes that I have. But 2 are my favorable ones, so that would be 2 out of 4. Or we can simplify this and say that the probability of drawing a green at random from this little small pile is 1 out of 2. Or we could say 50%. So it's equally likely that I can either get a green or not a green. All right, now let's look at black. Because there's only 1 black out of 4 possible incomes, I have about a 25% chance of drawing black. And it's the same thing with brown. I have a 1 in 4 chance of drawing a brown out of my 4 here, and that's about a 25% chance. So I'm not very likely to get a black or a brown, but I've got about a 50-50 chance of getting a green, okay? So this is the theoretical probability of what might happen. Experimental probability is when I actually do the event. In this case, the event, or what I'm trying to do, is just picking things at random. So I'm going to do my best. What I'm going to do is I'm going to kind of shake it up to the best of my ability under my hand. You can use a cup or something, whatever you can. And I am going to literally pick one at random. And I'm going to pick this one, and I got a brown. So I'm going to kind of make a little mark here in my little section that I've given you. All right, so I've picked a brown. I'm going to go back, throw it in, mix it up to the best of my ability, and I'll pick another one at random. And again, I don't know what I'm picking. Hey, I've got a green, all right? I'm going to continue to do this on camera for a total of 20 times. And I want you to do the same thing. I want you to pick 20 times at random and continue to mark it down. So I got another green. So I'm going to do this, and I want you to do the same thing. All right, so I have done my 20 times, as you can see on camera. There was actually a couple of times in there I had to redo it because the cube flew out my hand. But I picked it totally at random 20 times, and this is what I've got. I picked green 9 times, I picked black 4 times, and I picked my brown 5 7 times. Let me make sure that's correct on my mind. 9 plus 7 is 16, plus 4 is 20. So yes, there we go. So that's what happened. So let's look at the actual experimental probability. So when we do this, it says the number of times an outcome or event occurred. So I did picked 9 times out of 20 trials. So for my green, my black was 4 out of 20, and my brown was 7 out of 20. So if we were to kind of change this to a percentage, let's see what happens. Let's see, 9 divided by 20 gives me about 45% of the time I got this. My black was 4 out of 20, which was about 20% of the time. And my brown, interesting enough, was about 35% of the time. Sorry, I went off screen there. But I want you to look at it. So this was my theoretical probability that about 50% of the time I'm going to get green, and a quarter of the time I'll get black or brown. And if we were looking at this is pretty good. I don't know, your numbers may be different. Maybe yours were just slightly higher or lower than mine. Now, here's the beauty of it. If we were to take my numbers and your numbers and all the other students' numbers and put them together and do a comparison, which we might end up doing before this day is out, we should probably get closer to our theoretical probability, because the more trials that we do, the more problems that we do, we should see that it's coming closer and closer to a theoretical probability. In this case, it's not too terribly bad. 45%, 20, and 35%. Not too bad. Now, let's look at some things that are actually in regards to numbers. So it says, use the bar graph to find the experimental probability of the event. Drawing red. So before I look at all of this stuff, let's look at our little chart. It says I have the color drawn across this x-axis, so we have all these, and then it says the number of times drawn. So what I like to do when it comes to graphs, this is just a personal thing of mine, it's not necessary to do this, but it may help you, is to write the numbers there so you can see it a little bit better. And quickly at a glance. So if we were to look at 4, excuse me, I already gave the answer. If we look at blue, we see that it was drawn 4 times. So I want to write that there. This red was drawn 6 times, green was drawn 4 times, yellow 2 times, orange 3 times, purple 1 time. All right, so we want to know the probability of drawing red. Well, we know that we drew it 4 times. But how many times did I draw? Let's find out. Let's add everything up. I'm going to go 4 plus 6 plus that 4 plus 2 plus 3 plus 1. Make sure that's right. 4 plus 6 plus 4 plus 2 plus 3 plus 1. And, there was 20 times. So there was 20 trials here. All right, so what I have here is 4 out of 20. And again, we can change this into various things. We can reduce it to find out that it would be, let's see. Sorry about that. I was looking at the number red for some reason, and I misread this. The actual time I actually pulled out red was 6. So my bad on that. Anyway, that should be 6 over 20, not 4 over 20. I just looked at the wrong column, and it's easy to do that. Hey, glad I made the mistake. With that being said, I can go 6 over 20. I can reduce that to 3 out of 10. And if we want to take this even farther, I can do this as a percentage. This would be about 30%. So 30% of the time I picked red. Drawing orange, so the probability of getting orange would be something out, let's see, 3 out of 20. And if I want to change that to a percentage, I can. So 3 divided by 20 gives me 0.15, or about 15%. And notice that all of these are interchangeable. That's the thing about fractions, percents, and decimals. You can interchange those just like you already know. It just depends on how you want to present your information. Personally, I would always want to do it as a percent because most people understand percentages more than they do fractions, but either way is fine. Why don't you try number 3 and number 4 on your own? So for number 3, you should have got that the probability of not drawing yellow was 9 out of 10. And then for number 4, this one was actually kind of a fun one because you had to think a little bit outside the box. The probability of drawing a color with more than 4 letters is about 1/2. So how do we go about doing that? Well, just to kind of show it, we would look at each individual color. Blue has 4, this has 3, this has a total of 5. This has a total of 6, this has a total of 6, this has a total of 6 as well. So these are the words that we're going to be using, so these are the colors that we're going to be using. So I would go 4 plus 2, that's 6, 9, and 10. So I have a 10 out of 20 chance of picking one of these colors because that are more than 4 letters, and 10 out of 20 is equal to 1/2. All right, so number 5, we're going to actually take this one and pause on it for just a second, and we're going to come back to it at the end of the video. But I do want to just kind of mention 6, 7, 8, and 9. This one's pretty straightforward. These are use a number cube to determine theoretical probability. So this is not wanting the experiment because we're not doing the experiment. It's just wanting to know the theoretical probability. What are the probability of an event to happen? So a rolling a 2 off of a cube. Well, we know a cube has a total of 6 sides, and we already know that that cube only has 1. So the probability of rolling a 2 would be 1 out of 6. Rolling a 5 would also be 1 out of 6 because there's only 1 5 on a cube. Then it says rolling an even number. Well, the even numbers that are on a cube are 2, 4, and 6. That's 3 possible favorable outcomes out of a total of 6 when we can reduce that to a 1/2 probability. Then it says, lastly, rolling a number greater than 1. Well, the numbers that are greater than 1 are 2, 3, 4, 5, and 6. So that's a total of 5 numbers that are greater than 1 out of 6 possible numbers that you can roll. So you have a theoretical probability of 5, 6. All right, so we're going to go back to number 5. All right, number 5, it says that there are 25 students' names in a hat. You choose 5. 3 are boys' names and 2 are girls' names. How many of the 25 names would you expect to be boys' names? And what we're basically doing is making a prediction. This is not in your notes, but I'm going to kind of give you a Mr. Lewis definition here. A prediction is an assumption based on experimental probability. So we're going to assume that this pattern that we see here is going to remain true. All right, so what am I talking about? We, a while ago, chose 5 random names according to this problem, but 3 of them were boys, okay? So we're going to assume that 3 out of 5 are boys. So for a total class, doesn't matter what size the class is, it says that for every 5 students, 3 of them were boys. That's our assumption. That is how we're going to make a prediction. And here's what we also know. We know that there are a total of 25 students' names. So we can set up a very basic proportion. We know that this is our experimental probability, 3 boys for every 5 students. And so if we were to make an assumption that this is always going to be true and it will not change, we can do cross multiply and divide by saying 3 times 25 is 75, divide by 5, and I get 15. So we can make the assumption that there are 15 boys in this class of 25. So there's 15 boys' names in this list based upon our experimental probability. Is this necessarily true? No, it is not. We've only picked 5 names. So what happens if I pick, say, 3 more names? Could this number be changing? Yes, absolutely. It could change. It could be more boys or more girls. So this is where it's a prediction. There's not a guarantee that we're right. We're just basing an assumption off of what we already know to be true. And so it's just a matter of setting a proportion. So number 5 is a little bit difficult because it's asking you to take something and make a guess. So please, when you get to these types of problems, make sure you come talk to me because there's several types of examples about this. And I don't want you too confused. So anyway, experimental probability is what you do is the actual percentages of the experiment, where theoretical probability are the actual percentages of before the experiment, what it could be. And that's it for this video, and I'll see you in the next one. Bye-bye.